Everyone, thank you for watching our presentation. We are Group 4 and our presentation today focuses on a critical aspect of research, especially within the medical profession, developing survey instruments and collecting validity evidence. This is a systematic process essential for ensuring that the data we collect is both meaningful and reliable. To set the stage, let's look at the context of graduate medical education or GME. Surveys are incredibly important here. We see their frequent use in many areas. Think of resident satisfaction surveys, work hour questionnaires, trainee self-assessments, and end of rotation evaluation. However, a common significant issue is poor design, which is drastically reduce reliability and validity of the results. This is precisely why a systematic approach is necessary. Our goal today is to outline a systematic process for survey development and to guide researchers in collecting the necessary reliability and validity evidence. So, for our focus is on self-administered questionnaires. Next slide. Before diving into the steps, we must understand three key concepts: construct, validity, and reliability. First, a construct. This is a hypothesized concept, model, idea, or theory that is believed to exist but cannot be directly observed. In GME, constructs are often psychological in nature, like motivation, satisfaction, and perceived learning. Second, validity. This is the degree to which evidence and theory support a measured intended use. Essentially, are you measuring what you intend to measure? Third is reliability. This refers to the extent to which the scores produced by a particular measurement procedure or instruments are consistent and reproducible. A reliable score is necessary, but not sufficient condition for validity. A good questionnaire should consist of a set of items that every respondent will interpret the same way, respond to accurately, and be willing to motivated to answer. Next slide. The first crucial step is the survey right tool to answer my research question? Surveys are best suited for gathering data on opinions, attitudes, and beliefs. They are excellent for collecting information about behaviors that are not directly observable and for measuring those non observable constructs like motivation or satisfaction. For instance, a survey is helpful in assessing residents' opinions about new curriculum. They are also often to supplement other data collection methods. A quick note on survey design. Response anchors are the words or phrases like strongly agree, strongly disagree. The label each point on a rating scale. They are vital because they serve as a reference points to help respondent understand and interpret the options consistently, leading to clearer and more reliable data. Next. Once you have decided a survey is appropriate, step two, how have others addressed this construct in the past? You must review the survey that already exists in the literature and identify how others have addressed similar constructs. The best practice is to use or adapt validated survey when possible. Why? Because developing a new valid instruments from scratch is significant undertaking. However, remember that validity depends on a context and population. So even adapting an existing survey requires careful consideration. So step 3, how do I develop my survey items? Your item must be developed in accordance with the best practice of survey design. A key recommendation is to prefer construct focus response anchors over generic agree or disagree scales, where the construct allows. Crucially, you must draft items that capture all facts of the construct you are trying to measure. Finally, a common pitfall to avoid is negatively worded or ambiguous questions.
So step 4 is clarity of survey items. Here we ensure the content validity with the help of expert review. Experts assess survey items for clarity, relevance, and how well they reflect the intended construct. These experts may be survey methodologists, topic specialists, or knowledgeable local professionals. Items that are ambiguous or irrelevant should be revised and re-reviewed. This ensures that the survey truly measures what it claims to measure. For response clarity, we take the help of cognitive interviewing. Cognitive interviewing helps assess how participants interpret survey items. It involves detailed face-to-face interviews with some of the target respondents. Respondents explain their thought process while answering questions. For example, if a survey asks, how often do you engage in physical activity? A respondent might explain they considered only formal exercise, excluding daily chores, which might indicate the question needs clarification. This also identifies potential misinterpretations or biased wording. For example, if a question asks, do you agree that public transport is unreliable? The word unreliable might bias respondents to agree. Cognitive interviewing might reveal this, prompting a revision to a more neutral phrasing. Step 5 is the pilot testing and reliability analysis. Pilot testing collects data to assess item distribution and score reliability. Pilot testing is a trial run with a small sample of the target population where they complete the survey in the planned format. The data obtained are reviewed to check how responses are distributed across options and to evaluate the consistency of responses. Descriptive statistics such as mean and standard deviation in histograms help assess if items function as intended and if any items show problematic distribution. Cronbach's alpha measures internal consistency of survey scales. It quantifies how closely related a set of items are within a scale. If multiple items are designed to assess the same construct, they should be moderately to highly correlated. Here is the formula of the Cronbach's alpha, where K is the number of items in the survey. In numerator, we have the sum of the variance of individual items of the scale, and in denominator, we have the variance of the total scale. Cronbach's alpha values above zero point 0.7 usually indicate good reliability. However, it is sensitive to scale length, so longer scales tend to have higher alpha values. But if the alpha value is more than 0.95, there might be some chances of redundancy of items in the scale. Further, longer scales tend to have higher reliability, but risk respondent fatigue, as you can see in the picture. Also, reliable scores are necessary but not sufficient for survey validity. Reliability means your survey scores are consistent, and stable validity means your survey actually measures what it intends to measure. Scores must be reliable to valid, but reliable scores are not automatically valid. Here we have an example of response fatigue. A pilot test of an employee engagement survey in an Indian IT company revealed high Cronbach's alpha but identified fatigue effects due to survey length. As a step 6, we can have the validation of composite score. Composite scores average multiple related survey items within a scale. They help measure abstract or subjective constructs like attitudes or perceptions. These scores can act as an independent or dependent variables in analysis and can be validated by checking if they relate to external variables as theory predicts. A composite score assessing rural students' attitude toward digital learning in India might correlate with their household internet access. The digital divide and differential access to the internet among Indian students has been documented in many surveys. By following these steps and collecting reliability and validity evidence across time, settings, and samples, researchers can improve the quality of surveys as well as the validity of conclusions drawn from these surveys. Thank you.